So today I'm going to try and repair an X-ray sensor. This X-ray sensor was repaired a few years ago, and what usually happens is the wire gets broken right here, somewhere either in here or inside there. And these are, I think, sonically welded, so they do not come apart easily. So the way I usually repair them is I cut this out, resolder the wire inside there. It's a pretty delicate process, and then I fill it with some gasket maker silicone, and then over that I fill it with epoxy that is safe. That's not gonna like leach anything nasty out, since this goes, I mean, it gets covered in plastic before it goes into somebody's mouth, but still. So there you go. I'm gonna try, and I've never had to re-repair one. This is the first one, so we'll see how it goes. Gonna see if I can remove this epoxy without using a Dremel. Since if I end up having to use a Dremel, I'm not really going to be able to show it on video, because it's pretty complicated and noisy when that is on. So hopefully I'm able to just open it up using a knife. I should be able to. Hopefully it doesn't damage the little flex board that that wire is attached to. I mean, I do have spare parts for these, but they're really, really expensive. So I try not to damage when I take it apart. Well, it looks like it's gonna come out all right, actually. Yeah, that will come out all right. Okay. I'm trying to crush that. It's interesting to see which wire is the one that broke this time. Usually it's the ground wire that breaks for some reason. So far, just about every sensor that I've repaired, it's either the ground or data negative, I think, is what was broken. These seem solid. Actually, it could have broke past the nut, so let's see. Let's try and yank this out. I'm gonna cut this off right here. Come That gasket maker is stuck pretty good. Okay, I think that's good enough. Okay, let's desolder that. Where the heck's my soldering iron? Okay. To thoroughly disinfect and clean that. Where'd my tweezers go? I guess I can use these. Okay. That's good enough. So let's figure out which wire gave up this time. So let's try our negative. Looks like negative is fine this time. Positive, also fine. Data positive, that looks fine as well. Data negative, actually, all of them look fine. What the heck is going on with this sensor? Let me thoroughly test these wires electrically. Maybe I'm looking. I haven't tested it when the customer handed it to me. So it is possible, it's conceivable that the wire broke somewhere else. You know, it looks like it may have broke over here at the plug. Anyway, let's check these wires and let's see what's going on. Yeah, this one's good. Oh, come on. This one is good. This one is good. And this one is good as well. All right, well, it's nice to know that these repairs actually hold up for quite some time. And I think the problem is with this side of the cable this time. All right, let's grab this spare cable here. These cables are very tricky to deal with. Problem is that these, the mesh is very, very brittle. And so what ends up happening is people bite the sensor and eventually the mesh breaks. And then all kinds of issues result from the mesh breaking. And then the wires flex in that spot where the mesh has broken. They flex more, and so the wires end up breaking. So it starts working intermittently and then stops working altogether. is what usually happens. So and the original sensor has this strain relief that ends up breaking, and the way this wire is done originally, it just goes into here. It's soldered with little loops almost straight down, and then it's epoxied in, and that epoxy, the initial removal of that epoxy is extremely difficult. So, but because of the way it's done, once this strain relief breaks, this becomes the point where the wires start to break. And so that is usually one of the failure points. And then once the wires, like if the insulation breaks, the dust from mesh gets shorted out and stuff. So there's all kinds of different problems with the design of this interface. The way I mitigate that on my repairs is I usually tie a knot, and then I fill it with a gasket maker silicone, so there's enough flexibility to where there isn't a sharp pinch point like with epoxy, and then I cover with epoxy over the silicone. This is Teflon wrapped wire. So I'll carefully remove that. Now I'm going to remove the extra plastic strands that are sort of like fillers. Just making sure that none of the wires are damaged, and then I'm trying to remove as much mesh as possible so I don't have to deal with it. And then I'm going to kind of shift the outer silicone sheath a little bit so it kind of covers it. Sometimes the insulation on one of these is kind of stubborn and it doesn't want to come off, or it takes some strands with it. In those cases, I usually have to basically cut off, restrip, and start over. This time it went pretty smoothly. So for these type of repairs, I usually use silver solder rather than basically it's a lead-free silver containing solder, just because it's a medical device, so I try to make sure, and then I either use a separate soldering iron or I clean it a few times. If I've used it with lead or with lead-based solder, I will clean it a few times before soldering with the lead-free to make sure there is no contamination. So then I will tie this in a knot. That's the difficult part because it tends to want to jump out. And there's very limited space inside the sensor to fit it, because I gotta fit it in there and make sure that I can still epoxy over it. So that's kind of the difficult part, especially with a brand new wire. The old wire is a little bit easier to work with, but since I'm having to replace it, I'm having to use a brand new wire. So it looks like this one is not going to fit this way around. So I'm going to have to try and fit it this way around. It's going to have a little bulge after the repair. Okay, put a bit of solder on these pads, and then I'm gonna put a little bit of a rosin marker on the wires themselves to make sure they can reflow nicely. Come on. Okay. Goodness, this one wants to be difficult. don't know if that's going to be a good shot, but I have to contort myself to be able to reach everything and not damage anything in the process. So sorry if it doesn't look too good on video. So the green is on. Now onto the white. It is pretty difficult sometimes holding the other wires out of the way and having the one you need to solder where it needs to be, because there's not really much room to work with at all. Oh, and the worst of all is the knot just untied itself, which means I have to desolder and start again. That is annoying. Let me try tying it the other way, see if that's going to be easier. Come on. There you go. Okay. So let's try that again. Let's see if this is going to fit. Actually, this will fit a little bit better, I think. Yes, it should fit a little bit better. Now let's try soldering again. Okay. See if this works. There you go. I think that one went on pretty good. Yes, it did. Okay. Let's go for the second one. Yeah, these are kind of difficult to get in position. Because that wire is in the way. See, when they manufacture this, they do that before they assemble the two halves of the sensor, which we don't have the luxury of doing because I haven't been able to find these sensors, like the parts, the halves that are disassembled. And then I've seen other people do repair, but they 3D print those parts, and the doctors end up hating those afterwards because they're not the same quality of material as the original sensor, and they start falling apart. And some of them have a weird taste or smell. Okay, I think I've got the second one. Now let's get on with the third one. Okay. And then we've got the positive. We still gotta attach. And that one does not want to go where it's supposed to. So let's see if I could get it in place with tweezers. And then I'm gonna try and solder it once it's sitting where it's supposed to. Yes. Okay. That looks like we've got everything attached. Yeah, that's nice and free and clear. Okay, let's disinfect this again. And let's clean off The next step is to test the sensor, make sure it passes all the tests, and then we could start epoxying it. That'll mix the epoxy very, very well. And there you go. In about 8 hours, the epoxy is going to fully cure and the sensor is going to be usable again. If you find what I do interesting, subscribe, share, like. I have lots more interesting projects and repairs that I can do. And if I see interest, then I'll start posting more of it to YouTube. Thanks. Bye.